Hi everybody. We're back and we're going to do the same problem. Well, not the same problem, but like different numbers, but we're going to go the opposite direction. We're going to start with scalar components. We're going to start with an f in the x direction and an f in the y direction, and we're going to find the resultant force. So here we have a minus 10. Put the minus sign there. Minus 10, so it's going in this direction. That's minus on the x direction, but it's going positive on the y direction in 3. And these are in newtons. Newtons is the metric equivalent of force. Last problem we were using pounds. But newtons are very common. They're named after Isaac Newton, and they're really quite small. So this is actually a very small force. Newtons are, well, Newton himself was kind of diminutive. So as a result, the force that's named after him is kind of diminutive. Oftentimes you will see kilonewtons or meganewtons or even giganewtons as forces. So you'll see those modifiers to the metric system that you should all be very familiar with. So yeah, a lot of times they're not measured in pure newtons. It's actually pretty rare to see newtons in any of the things that we deal with, because otherwise we're talking about maybe what it takes to tear a piece of paper.
If that.
If that.
Yeah.
So, all right. So the way that we do this, we've got two sides that we have determined here. Well, we've got two sides of the triangle. We can figure out the third side of the triangle just using Pythagorean theorem. So we're used to seeing the whole a squared plus b squared equals c squared, right? That's what we learn for Pythagorean theorem. Most of the time here we're going to do a little like pre-algebraic manipulation to get c on its own. So what we do to get c on its own is we take the square root. So c equals the square root of a squared plus b squared. So that's really where we're going to start most often, is just using that. So C is this line right here. We're trying to figure out this resultant force, and that is the hypotenuse of a right triangle. And we can use either theta or the other angle over here, but this is the right angle, right there, with a side of 3 and a side of 10. So we do 10 squared. So C, do this over here, C equals the square root of 10 squared plus 3 squared, or C equals 100 is 10 squared, 9 is 3 squared, so that is the square root of 109, and that C equals
10.44.
10.44. Thank you, Mike, as calculator. And that's in newtons.
Yes, that's in newtons. Very important that you keep your units.
I'm just going to write this up here on that. 10.44 newtons is that vector right there. And since we've got a magnitude on it, I might as well put the sense on it because I didn't draw that earlier. It's going in that direction. That's the sense.
Yeah.
Because you got to have a sense of which direction you're going.
Absolutely.
All right. So now we have all three sides to the triangle, and what we're trying to do is find the angle. We only need two sides of the triangle to find the angle, because we can use the inverse functions of the trigonometric functions. So tan to the minus 1 of the ratio here is going to equal the angle.
Yeah.
So it's just inverse. It's working through it backwards. So on your calculator, you're going to find, usually by hitting a second function, tan to the minus 1 as opposed to, or cosine to the minus 1 or sine to the minus 1. We can use, because we know all three sides of the triangle, we can use any one of them. But we haven't used tangent yet, so we'll use tangent. And tangent is what? It is
The adjacent over.
no, it's the opposite over the adjacent.
Yeah, TOA.
TOA.
The TOA, sorry.
TOA. TOA.
Sorry.
Right?
Opposite over adjacent.
Opposite over adjacent. So for theta right here, opposite over adjacent would be 3 and minus 10.
Yep.
Right? So we're going to drop the minus because we know which direction this is going. We'll add the angular equivalent to that a little later. But it is 3 divided by 10. So it's 10 to the minus 1 of 0.3, because that's 3 divided by 10.
Yeah.
Equals, and if we plug that into the computer,
and we do our math, we will get 16 degrees.
16 degrees.
Approximately.
And that's what theta is here. Pretty simple. It's just we're plugging it into the calculator, and this theta now is 16 degrees. Now, that 16 degrees is in the minus direction from the x-axis because of how we treated this triangle. Because this direction is minus, and this direction is plus. And that's just a simple convention that is used. And it's because in the positive side, you are moving the y more positive this way. And in the negative direction, you're moving it less positive.
Right.
So it's hard to wrap your brain around. You think of clockwise as being the right way, so it should be positive. No, it's actually the opposite. It's okay as long as you keep things in mind. As long as you keep it the same, you will be okay.
The math will work out.
And as long as you clearly state where your reference point is, we're talking about 16 degrees above this. It's also going to be the complementary angle, which would be 74 degrees in the positive direction
for y.
For y,
Yeah.
from the vertical axis.
Yeah.
So as long as you're very descriptive to that, you can do whatever. And of course, we could do this with the other angle and just flip which way we did it.
Yeah.
Flip this tangent upside down, so it would be 10 divided by 3.
Yeah.
And we would get the same answer. So there you go. That's finding the resultant vector from two scalar components. We will in the next episode learn how we do addition of multiple vectors.